Welcome to a new video. Our lesson today is on reflections. A reflection is another type of rigid motion. The notation for reflection is a lowercase r, and the subscript, I'm going to redraw that r for you. Our subscript is a line. Now, sometimes that line is an axis. Sometimes it's just a line on your figure. So it might say x-axis, it could say y-axis, it could say y equals x. Any of those lines could be in our subscript. So let's look at example 1. Here I have a grid. I've plotted our pre-image for us. This is our pre-image, and we're going to find, once it undergoes a transformation, this is going to be our image. So in this case, the notation is telling me to reflect across the y-axis. So when I reflect across the y-axis, what I'm going to do is I'm going to determine where my line is and how far away my points are from that line. In this case, B is exactly on the line, so B won't move. So I'm going to rewrite here B prime as 0, 4. For A prime, I see that A is 1, 2, 3, 4, 5, 6 units away from my y-axis. So what we can do to determine where A prime is going to be is to count from A toward the line. So again, 1, 2, 3, 4, 5, 6. And then you're going to continue past the line and count another 6, the same distance. So 1, 2, 3, 4, 5, 6. Here's point A prime. And I can name that point right now if I would like. That point is at -6, 0. And now for C to C prime, we're going to do the same thing. From C to the line of symmetry, or well, I guess it is really a line of symmetry, isn't it? It's a reflection. So yeah, it is. So to that line is 1, 2, 3, 4, 5. And so I'm going to continue 1, 2, 3, 4, 5. Here's point C prime. I'm going to get rid of those little hops. And I'm going to name that point, and that point will be at +5, -1. An invariant point, you might hear that term. That means that a point that did not change position. So in this case, the only point that did not change position was point B. And then here it says what is true about the image and the pre-image. So what I want us to write here is that the image and the pre-image are congruent. And why are they congruent? It's because a reflection is a rigid motion and rigid motions preserve distance and angle measure. We're going to try two more graphs and reflect them across a different axis of symmetry. Here we go. So here is number 2. Again, we already have it plotted. This time we're going to reflect across the line y equals x. So the line y equals x is the line that goes right here. I'm going to draw it in black, I think. The line y equals x is anytime the y value is equal to the x value. If you were to type it into your calculator, you would see that it is that line exactly there that I've drawn for you. It's a diagonal line. So what you can do to find your image is you can count perpendicular to your line to determine how far away it needs to be. Just like before, we're going to determine how far away it is from the line. But we have to be careful to count perpendicular to our line. So let's start with point C because it's closest to the line. To get from C to the line, I would count a diagonal 1, 2. And now I'm going to continue. 1, 2, and here is point C prime. Again, I can erase some of these extra lines in here. Oh, not that line though. Some of these extra lines. Let's try point B. When I go from point B, I'm not going to go and follow the line from A to B because that's not perpendicular to my line. Instead, I'm going to go directly diagonal. So 1, 2 to the line and another 1, 2 to the new spot of point B or B prime. And then I'm going to follow the same method for point A. 1, 2, 3 to the line, 1, 2, 3 to its new location, A prime. I'm going to just get rid of some of these extra lines so that when I draw my triangle, it doesn't look so crazy. Here is our new triangle, A prime, B prime, C prime. So my new point A prime is at 0, 6. B prime is at 4, 0. And C prime at -1, -5. Do I have any invariant points? I do not, so there are none. All right, our last one for today is a line that is like x equals 2. This is an interesting one. So if I tried to graph that in my graphing calculator, I could not, right? Because our graphing calculators only graph y equals, and this is an x equals line. So when we think about the x-axis, we know that x is 2 right here at this point, but we're not reflecting across a point, we're reflecting across a line. And the line x equals 2 is the line that's vertical, that goes through the point where x is equal to 2. Because any of these points on this line, if I named any of these points, x would be equal to 2. So now I'm going to actually use purple this time to reflect across that line. So again, I'm going to start at B. So 1, 2 to the line, 1, 2 in the opposite direction to get B prime. A is 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4 to get to A prime. And from C to the line is 1, 2, 3, 4. Ooh, hold on. 1, 2, 3, 4, 5, 6, 7. So I'm going to continue and go 1, 2, 3, 4, 5, 6, 7. C prime. And now let's name all of those points. A prime is at -2, 0. B prime is at 4, 4. And C prime is at 9, -1. Are there any invariant points? There are not.